Welcome back and welcome to the Unit 2 of the Open Elective course on narcotic plants. In this unit, let us understand the various details about the drugs, general drugs, the types of drugs, orphan drugs, designer drugs, pharmacokinetics, drug action, mechanism of action of drugs, drugs absorption. All these are the topics that are included in the Unit 2. We will understand all these things in this unit. Welcome to the Unit 2 of the Open Elective course on narcotic plants. In this unit, let us understand general drugs, designer drugs, drug abuse, mode of administration of drugs, and pharmacological action of drugs. These are the various definitions of drugs. A medicine or other substance which has a physiological effect when ingested or otherwise introduced into the body. It may be any substance other than food that is used to prevent, diagnose, treat or relieve symptoms of a disease or abnormal condition. There are other definitions also, but we are looking into the narcotic drugs. There are some types of drugs such as opioids, heroin, opium. So there are a number of narcotic drugs which are abused, which are generally leading to addiction. And the main focus of this open elective course is to understand the narcotic plant from which the narcotic drugs are produced. There is a classification of drugs. So drugs are classified into different categories. Drugs that affect the central nervous system, CNS stimulants, hallucinogens, under which we come across the narcotic drugs, and also we have anesthetics. So this is a simple classification of drugs. Mainly the drugs affect the central nervous system. You are seeing the central nervous system here. The next category of drugs are narcotic analgesic. The analgesic drugs which are relieving the pain that are derived from the narcotic plants are called narcotic analgesic. Basically, narcotic plants were used to produce the analgesics. Now they are being abused. The sixth category of drugs is inhalants. Seventh is cannabis. There are a number of other classifications of drugs. We are basically looking into the narcotic drugs because that is the focus of this open elective course. Coming to drug nomenclature. Generally, drug has three categories of names. A, chemical name. B, non-proprietary name, that is the official name. Third one is the brand name. For example, if you take crocin, has a brand name that is called crocin, and the chemical component that is found in the crocin is paracetamol. There are different brands of paracetamol. One of the popular brands of paracetamol is crocin. There are some categories of drugs called essential drugs or general drugs. They are defined by WHO as those drugs that satisfy the healthcare needs of the majority of the population. They should therefore be available at all times in adequate amount, in sufficient amounts and appropriate doses, forms at a price that is affordable to a common man. So these are called essential drugs and they are controlled by the WHO. The next category of drugs are called designer drugs. These are not natural drugs. They are man-made drugs. They are designed by the scientists as a new chemical entity. They are produced in the laboratories by the scientists. So they are designed by various methods. One of the most recent method of designing a drug is called computer aided drug designing. and we have a very common designer drug that is available in the market is Ecstasy. We also have Zyhydro is a designer drug. So these are the drugs which are manufactured synthetically by the scientists in the laboratories. They are not naturally available. There is one more classification of drugs called orphan drugs. Orphan drugs are the drugs which are developed for orphan diseases. The diseases that are not very common, the diseases that they are there in only a small amount of people. So these are drugs or biological products, or also diagnostic kits that are used in the treatment and prevention of rare diseases, more uncommon diseases. So these drugs are called orphan drugs. For example, we have sodium nitrate, and we have fomepizole, and we also have liothyronine, and there are many kinds of drugs that are developed for orphan diseases. Orphan diseases are the diseases which are very, very rare. They are called orphan because the major drug companies don't bother about these diseases. Because when a pharmaceutical company wants to develop a drug, it always looks at the profit. If it is used by a large number of people, large population, then they get more profit, more benefit. And if it is required by a small section of people, they don't get much profit. And hence, the pharmaceutical companies don't develop the drugs for the orphan diseases. So these are called orphan drugs. There are laws, rules, regulations that are set up by the government. They are called laws governing the drugs, against the drug abuse. These are the 5 schedules which are included in the government organizations to control the drugs. Coming to the next topic, that's called pharmacokinetics. This is nothing but the process by which a drug is absorbed, distributed in the body, metabolized and eliminated by the body, and this process is called pharmacokinetics. There is one more term called pharmacodynamics, and this is nothing but the interaction of drug with the receptors responsible for the action in the body. There are 2 important phenomena that we must understand. One is called pharmacokinetics, which actually explains the mechanism of absorption, distribution, metabolism, elimination, excretion of the drug in the body. And the other one is pharmacodynamics, which is nothing but interaction of drug in the body. When the drug enters your body, the receptors accept the body, how actually it initiates the action, mechanism of action is studied under pharmacodynamics. The life cycle of drug is called pharmacokinetics, and as I mentioned in the previous slide, there are 4 steps: absorption of the drug, how the drug is absorbed by the body. Second step is distribution, how the drug is distributed all over the body. Generally, the drug is distributed all over the body through blood, and how the drug is degraded in the body. It has to be degraded before it is bringing about the action. And finally, how the excretion of this drug or the products of the drug are released to the outside by excretion. So this is what is the life cycle of the drug in the body of a human being, and this also is called pharmacokinetics. Coming to the mode of administration, how do you take the drug? The drug can be generally orally consumed, like a tablet. I think every one of us know this. We swallow a tablet. If you have headache, we swallow a crocin or a paracetamol tablet. So you keep it in your mouth, drink some water along with the tablet, goes in. This is oral. If it is a tablet, if it is a liquid, if it is a syrup, we just drink it. Next is through mucous membrane, and this is by oral mucosa, nasal mucosa, or the drug may be administered through tropical transdermal method, that is through injection. And the fourth category is rectally, through the anus the drug is ingested. So the drug can be introduced into the body of a human being by various methods, and this is what is called mode of administration of drugs. And there is one more classification of mode of administration of drug through, and this is by injection. Okay, hypodermal injection we call it. That is, the injection can be intravenous, it may be intramuscular, it may be subcutaneous, or it may be intraperitoneal. So depending on the type of ingestion, type of injection, type of introduction of drug, we have different classification of administration or methods of administration of drugs. Or drugs may be inhaled through lungs, or drugs may be directly released into the brain. It's called intracerebral and intracerebroventricular. So the general principle of administration of drug is faster the absorption, quicker the onset, higher the effectiveness, but the shorter the duration. So doctors and medical practitioners use the specific method of introduction or administration of a particular drug in order to see that the drug is absorbed very well and the drug is acting on the body quickly and effectively, efficiently. So these are the different modes of administration of drug. The next part is absorption, solubility. Depending on the chemical nature of the drug may be water soluble or drug may be lipid soluble. Depending on what chemicals are used that are used to make a drug, the drugs may be water soluble or lipid soluble. Based on that, the solubility of the drug occurs in your body. The mechanism of action of drug depends on the type of the drug. The water soluble drug has a different mechanism of action. The lipid soluble drug has a different mechanism of action. I am not giving too much of importance to these topics because this is not the main focus of our course. Our main focus of our course is narcotic plants from which narcotic drugs are produced. But we must have the basic idea of drug. That is why we have included all these topics into the course. Otherwise, this is not very important for us. Coming to the distribution of drug in your body, it depends on the blood flow, blood-brain barrier. So whenever you take the drug into your body, the drug has to go to different parts. There are general drugs. General drugs are the ones which we take in the mouth or from any place, and they go to all over the body, including the part which is affected. For example, if you have a pain in your toe or in your leg or in your feet, you have to take the drug in your mouth. The drug travels all over your body and also goes to the place where it is affected. So these are called general drugs. And there are some specific drugs which are administered only to that point where the part is affected. For example, there is a person with a brain tumor, and the brain tumor has to be killed and has to be destroyed. And there are drugs given only to the tumor, directly to the tumor or the place where the cancer is seen, so that only that part is affected and only that part is destroyed. Sometimes what happens in chemotherapy, the drugs are given generally all over the body. That is why there are side effects of the drug. So And when we take the drug, the body has some barriers. See, some portion of a body cannot or will not receive the drug. It has a resistance to receive the drug. So we have to develop different kinds of drugs in order to break the barrier. So thus, distribution of the drug is another important part of pharmacodynamics. Some of the drugs which are ionized are excluded. Some of the drugs require active transport mechanism. We have to include an active transport mechanism so that the drugs are absorbed by your body effectively. The next important aspect of drug is bioavailability. If you take 10 milligram of drug, let's say crocin or paracetamol, the entire 10 milligram of drug is not available for the mechanism of action, not available in the bloodstream. So the amount of drug that is available in the bloodstream for action is what is called bioavailability, and it is determined by various factors. For example, physical properties of the drug formulation, if the drug is administered in a fed or a fasted state, gastric emptying, circadian differences, interaction with the other drugs, age of a person, diet of the person, gender, disease state. So depending on various factors, the availability of the drug in the bloodstream is depending. So based on this, the medical practitioners or the doctors will administer the drug. The amount of the drug used is determined by all these factors. Coming to depot binding. So whenever the drug enters your body, the drug is accumulated in fatty tissues. Drugs bind to depot sites. They are called silent receptors. They are in the fat, they are in muscles, they are in organs, or they may be in the bones. These depot binding reduces bioavailability. So if you take a drug, the drug goes and binds to a certain depot site and it is available there, it is deposited there, and hence it is not available for action. It actually slows down the process of action, and it also can cause drug detection window. So hence the important factor that we have to look into is depot binding. Depot bound drugs can be released during sudden weight loss, may account for flashback experiences. So one more important factor that we have to look into whenever we discuss about drugs or understand about drug is depot binding. Sometimes the drugs are deposited in the kidney, sometimes the drugs are deposited in the liver. These are two very common places where liver and kidney are the two important places where the drugs are deposited. Hence, the people who are taking too much of drug, they are taking regularly drug, and their kidneys and their livers are seriously affected. The next part of this unit is degradation or excretion of the drugs. Once the drug has completed its mode of action, and this is excreted, released to the outside. And in this case, the two organs that are very important, they play a role in this is, one is liver, the other one is kidney. And these two play a role in the degradation of the drug after it is used, after it has completed its action, and it is excreted to the outside. So it should not be deposited, it should not stay in your body, it has to be excreted to the outside, and otherwise it will cause problem. I told you already. And if the drugs are deposited, and if the drugs are staying in kidney or liver, your kidney and liver are seriously affected. Coming to the next aspect, that is action of drug. There are different mechanisms, there are different ways through which the drugs enter your body. So there is a direct action. You can see here there is direct action of metabolism, which is directly acting. There may be transport molecules through which the drug is acting. There may be cellular transport system for controlled action. Through ion channels the drugs enter. Sometimes there are neurotransmitter receptors, and they are receiving the drug. They play as the drug receptors, or there may be a hormonal control on the mechanism of drug action, and finally the drugs enter your body and bring about the action, and some drugs even bind to the DNA and bring about the action. So there are different avenues for the drugs to enter your body and bring about action, and there are different types of mechanisms of action. Depending on the type of the drug, the action or mechanism of action of the drug depends. So there are something called drug receptors, and there are drug receptors on the membranes of each and every cell, and these receptors will receive these receptors that are there on the surface of the cell will receive the drug, and these are macromolecular complexes that are there on the surface of each and every cell. So they receive the drugs, and these receptors will have receptor down regulation. When a receptor is continuously exposed to a drug, the receptors become active and they are receiving the drug and they bring about the action. This is known as receptor down regulation. So there is a drug, and the drug will bind to the drug receptor complex, and then the response or the mechanism of action of the drug begins. There may be reception upregulation, there may be reception down regulation, there may be reception down regulation, or there may be reception upregulation. There are two types of regulations as far as the mechanism of action of drugs are concerned. You can see here the ligand. Ligand is nothing but the drug, and there is a receptor that is there on the surface of the cell. Each and every cell has a receptor, and once the ligand is nothing but the drug, binds to the receptor, it enters into the cell and then bring about the action, and thus the response of the drug begins. This is what is drug received by the receptor, and there is a complex, drug receptor complex occurs and response is given. And the drug and the receptor, they work like lock and key. There is a particular drug for which there is a particular receptor, and that is the basic principle behind which that is the basic principle based on which a drug is designed. And when you design a drug, there should be a specific receptor, and if there is no receptor, the drug cannot be bound to the cell and no action is possible. So whenever you are designing drug, you have to have a particular receptor on the cell surface. These are the references. This is the bibliography. If you want to know more information, you can go to these books and read more about it. Thank you very much for watching. We will meet in the next unit. The details about this video are available in the description box down below. If you want more details, please open the description box and read. Thank you very much. Thank you very much for watching this video. The details about this video is there in the description box. Please open the description box if you want any further details. We'll meet again in the next class in some other video. Thank you very much.